Warm up number 74. So, we got our bell curve. What's our mean, Eddie? Mean is 10. Hands if you got 10 for the mean. Okay. And variance. Pass someone out, Eddie. What's the variance? 20. Looks about right. And standard deviation. Pass someone, Joseph. .47, that means this is the 14.47, and this is 5.3, no, 5.3, 5.53. That's the norm. Hands if you got something like that. Okay, good. So, that was using the shortcut formula. I saw some of you do the long way where you did the columns and all that. Let's try and focus on reviewing our formulas, guys. Okay? All right, copy the agenda, please. Warm-up number 74, interest and probability. Today we're pretty much done with the intro part, and today we're going to be focused on noticing the difference between classical and empirical probability. Classical and empirical probability. And from this point forward, this section of probability, when we're going through the different ones, even though it might be pretty straightforward for some of you are going to struggle a little bit with some of the ideas, so I'm trying to give you guys some time. We eased into this, and so just stay focused, please, pretty please, with a cherry on top. Your home plate for tonight is same from the end of the lesson 4.1, but you're doing exercises 15 through 18. 15 through 18. And during your text, however, I did take a screenshot and included them in this presentation. So if you want to copy the code, BGZ6I, you can access them with that code, BGZ6I, BGZ6I. All right, last night's home play was numbers 1 through 13. No. Yeah, 14, my bad. 1 through 14 only. So I'm going to pick those up at the end of the day because I had some issues with Canvas, so I'm working through those. Should be open by 3:25. Okay, so at the end of the day, turn that in. Tomorrow's once again 15 through 18. Okay, y'all ready? There's the home plate. It's only 4 of them, but each one of them has a lot of stuff. All right, I can identify basic probability. I can identify and compute basic probability. We're moving on. And like I said today, we're going to make sure that we understand the difference between classical and empirical. Classical and empirical. All right? So, with that said, did we start with definition for probability yesterday? Yes, again. Tell your neighbor the definition of probability by now. Without looking at your notes. Jaden, go. Help him out, Eddie. Yes, the chance of something occurring, an event occurring. We have that. We have this diagram as well. Is that correct? So like I said, we're done with classical. We're moving on to empirical. We have this formula for classical. And yesterday, I had you guys look for the formula for empirical, and you wrote down P of E equals F over N. Is that correct? All right, remind your neighbor once again, F, what does F stand for and the N stand for, please? What do those stand for? You guys all right? You guys all right? Yeah? Come on. Come back. Leave Barney alone. Did you guys grow up with Barney? Or are you guys Blue Clues, or what are you guys? Yeah, all that? Okay. We'll leave them alone. Come back. All right, here we go. So, S is frequency, N is the total number of numbers, yes? All right, so with that said, on your paper, I want you to write classical on the left side, empirical on the right side, and in the center, sketch me a die just like this. I mean, I know some of you are artistically challenged, but try your best, you know, make it look somewhat similar. All right. So, on the right side, I want you to make a table. Outcome and F. Once again, remind your neighbor what F stands for. Very good. Good communication, my goodness. You guys want some coffee or something? Yeah? Yeah, me too. I brought tea today, too. All right, so with that said, question. How many total outcomes in a die? Tell your neighbor. How many total outcomes? Chelsea? I'm sorry? 6. So therefore, write it out. Outcome 1, outcome 2, outcome 3, outcome 4, outcome 5, and outcome 6. All right. So, nice and neat like mine. Are we there so far? So this is what we're going to do. We're going to get into pairs. I'm going to give you this time only one die. And each of you are going to roll 3 times, and you're going to start recording the frequency of whatever comes up. For example, I'm going to be teamed up with MJ, all right? And I'll let him go first. MJ, go. He rolls, boom. 3 comes up, tally. 6 comes up, tally. 1 comes up, tally. My turn. 3 rolls, 1 comes up, 2 comes up, 5 comes up, and so on and so forth. Start tallying all your rolls, yeah? All right, so get into teams of 2, and send a gopher, come get a die, please. We're going to do that for a little bit. All right, so you have a lot of data, yes, on this table. Okay, so what you need to do now is for each, you're going to write the number of the total frequency of each outcome. So how much was it for number 1? So I'm going to use, let's see, Briseda. Tally 1. How many frequencies? 9. Okay. So tally all of them, please, right next to your tallies. Do that for your entire distribution table, please. All right. All right. Next one, Illy, for 2. 11. Yes? All right. For 3, Briseda. 11. For 4, Illy. 9. For 5, Briseda. 6. And for 6, 17. Okay. So, did everybody total their row? Yes? Now we're going to total this way. So total all the outcomes that you got, all the frequencies, find the sum of that. So I'm going to use this example. So we got 40, 63. Yeah? Okay. All right. Well, guess what? This is our n. So label that. That's our n. That's our n. Okay? So, at the top you wrote empirical, yes, so let's write our formula. By now you know it by heart, yes. P of E equals what? F over N, that is correct. And the F, speaking about a specific event, the frequency of the specific event. So, check this out. You're going to do this to your table. I'm going to use their example. So I'm going to start with number 1. Look up, please. There it goes. I'm looking at outcome 1. So I'm going to write P of 1 equals, what was the frequency for 1? 9 over, what was the N? 63. That is my total probability for 1. However, decimal form, calculators, calculate. What is 9 divided by 63? What is it? No, in decimal. 0.14. Write that over here at the end. We're going to need that. So I want you to write me the fraction on the left and the decimal on the right. So do that for your table. You already saw how we're going to use for each one of those. I'll give you some time. Go. All right. So let's see. I think we're ready. Brisela, what'd you get for the next one? 0.17. And the next one? 17. Next one? 14. Next one? 0.95. Okay. And the last one? 27. Okay. All right. We good? All right. So let's leave that for right now, resting right there. Let's go to the left side for classical. Make a table just like we did on the previous one. And you're going to write outcome. And here for the right column, we're going to write probability. Probability. Okay. So once again, how many outcomes do we have, everyone? So we got 1, 2, 3, 4, 5, and 6. And our formula, of course, P of E equals what? N of E, is that correct? Over N of S. Okay, so here we go. This is going to go really fast. Question. In one die, how many total outcomes? 6. Well, guess what? That's going to be our N of S. 6. Okay, so if I was to roll a die, what are the outcomes of rolling a 1? A 1. Yeah, 1, 6. How about a 2? How about a 3? Okay. Did we do anything with the die? No. Did we record anything? No, we're just looking at plain data from what we see and using that data to use our classical formula to find our probability. Okay? So, question. Here's a question from me to you. Now that you experienced the classical one, and now that we did the classical and you experienced the empirical, Talk it over to your neighbor, let them know what's the difference between classical probability and empirical probability. What's the difference between one to the other? What would be the major difference that you would tell? Go. All right. Jael got it. Very good. Fernando got it. Peyton's got it. Very good, Peyton. All right. Let's see. Let's wrap this up. How about Jaden? What's the major difference between classical probability and empirical probability? One has default settings. Which one has default settings? All right, let's write that down. Classical has a default setting, which means we see it from what we see, right? Is that what you're talking about? Okay. What we see. Okay. How about empirical? What would you say empirical is? Empirical. So in other words, we experience from capturing data. So we have to do something in order to get the data. All right. Does that make sense from one to the other? Yes? Once again, classical, straightforward. You can just look at it and get it. For example, let me ask you this. Y'all ready? If I was to give you a coin, okay, tell your neighbor how you can set up a classical and an empirical setting for just a coin. If I gave you a quarter for you guys to use a coin, talk it over to your neighbor. How would you go about that? How would you go about that? Setting up a table for classical and a table for empirical using a quarter. Think about it. You're in teams of two. Now I give you a quarter instead of a die. Mm-hmm. Mm-hmm. All right. Looks like Lenny's got it. Very good, Lenny. But we're going with Chelsea. How can we set up using a quarter now in teams of two? What would be the difference from one to the other, classical to empirical? What's that? Separate in half. So that means for the classical, we have a table with what? How many probabilities? 1 out of 2 and 1 out of 2. How about empirical? What do we know from just the coin? No, until we do what? Record all the frequencies and see what the outcome is at the end. Okay? Now check this out. One last thing before we wrap this up. Look up. 1 6 plus 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 1 6 is equal to what? 1. Do me a favor. Add all your decimals. Oh, yes. It should be very, very close. Is that correct? Hands if you got a number very close to 1. Yes? What can we conclude? That it doesn't matter which probability we use, the total of our probability or our outcomes has to equal to what, everyone? It has to equal to 1. That is correct. Whew, from the corner to, let's go. So, I'm going to stop right there, okay? Because I do want to make sure that we understand this before we move on to something more funner as we are getting there. Yeah, I know. Notice this one was a little bit challenging, right? To kind of like get that really through our noodle. However, what's up next, we're going to start encountering now situations with different things that we need to really understand. Is this classical, empirical, or subjective? So we're going to be now looking at 3 different type of probabilities, okay? So let's stop right there. And actually, let me send you the screen so you can send me your notes. I want to see what you wrote down. Give me a second. All right, so we got this done. You're sending me those. And then just really quick, last night I had you find me all these definitions, yes? So let me send you the screen for that one. Send me your definitions for that one. There it is. It's in front of you. And last but not least, the last terminology that I left you were the probability rules. Is that correct? Yes, Mr. Q. All right. So we're going to get to these a little bit more as we move along, but today we probably saw probability rule number 4, the sum of all probabilities of all outcomes in the sample space is what? 1. We actually experienced that here, okay? So let me send you the screen for that one. Anyways, here it goes. Send me your notes for that. And for those of you that are following along on YouTube, let me go back so you guys can see the code, because you're going to need that to access the home place. All right? Stop right there. Talk to you guys later. Bye.